Hello everyone. The topic today will be involving in this class will be molecular structures under the subcategory inorganic chemistry. So whenever we say molecular structure and in the subclass of inorganic chemistry, what would be our prime focus? We would be discussing few properties of a molecule which is fundamentally an inorganic molecule. We would involve the hybridization of that molecule. We would be discussing and learning to calculate the bond pair and lone pair of the molecule. We would be learning the geometry, and apart from geometry, the shape of the molecule. This would be our first concern. The second important thing that would be the application from these learning, and it would be to find out the isostructural molecules, electronic molecules. So if we consider something that is directly related to a competitive exam preparation, these are the things that we will be involving. Here in this lecture, we would not be going through the theory section, but we will be learning those tricks and tactics that would help us to get best answers in the minimum time, and those best answers have to be the correct answer. So let us solve the first phase, which involves hybridization, bond pair, lone pair, geometry and shape. Once we are done with this, we can easily solve the isostructural and the isoelectronic molecule questions. If you will go through many different question papers available on internet for several exams related to the entrance test of PhD or the entrance test of master degree program, there will be questions which will be involving hybridization, shape, geometry, number of bond pairs and number of lone pairs. One simple formula can fetch you to this answer in a very lucrative way. So, related to the molecular structure, the formula that we have to use involves, for a given molecule, calculate the total number of valence electrons. Let us start with an example also together. Let us write the example XCO3, xenon trioxide. We all know over here you have two atoms, one is xenon and second one is oxygen. Always remember, for inert gases other than helium, the number of valence electrons will be 8. And when we calculate for oxygen, you very well know that 1s2, 2s2, 2p4. So it is a total of 8 electrons, but this is the inner shell, so the outer shell is only considered as the valence shell, and therefore the total number of electrons in the valence shell will be 6. So over here it is very clear that xenon has 8 valence electrons, whereas oxygen has only 6 valence electrons. So calculate the total number of valence electrons. So the total number of valence electrons will be 8 plus 3 oxygen multiplied by 6, which will lead to 18 plus 8, that is 26. Now the point number 2, if the total of valence electron is between 2 to 8, between 9 to 56, 57 and above. You have to divide that number by 2, 8 and 18 respectively. So let us check over here. The number is 26. So whenever I have the number 26, it falls in this range, that is 9 to 56, and therefore I will divide it by 8. So it is 8, 3 times 24. I will end up with 2. So whenever I end up with 2, it falls in the first range. So I will divide it by 2. So it is 1 times 2 and my answer will be 0. Remember friends, minimum in 1 step and maximum in 2 steps. If you attain the answer 0, then and then only this formula works. And this formula works in more than 90% of the concepts. So, the first divisor and the second divisor that you get denotes the number of bond pair of electrons and the number of lone pair of electrons for sure. It means the first number that you get is always the bond pair and the second number that you get is always the lone pair. So I will write over here. First divisor equals to the number of bond pair electrons, and the second divisor, if sometimes you do not get the second divisor, then no lone pairs, indicate the lone pairs of electrons. So I hope you are getting what I am speaking, because this is a very important concept. Now, from this much idea, we can get most of the answers. So over here, I am ready with 2 answers. That is, for XeO3, the number of bond pair is 3. The number of lone pair is 1. So I am done with 2 of my answers. Now, you have to take a total of this. You have to take a sum of this. Let us check what happens. If I take a sum of this, 3 plus 1, the total is 4. Remember very well, if the total is 2, 3, 4, 5, 6 and 7 respectively, my answers would be SP, SP2, SP3, SP3D, SP3D2 and SP3D3. This is the way how it works. This is the way how it works. So friends, be very clear that if my total comes 2, the hybridization will be SP. If my total comes 3, the hybridization will be SP2. If my total comes 4, the hybridization will be SP3. If my total comes 5, SP3D, 6, SP3D2 and 7, SP3D3. So within this one exercise on the board, you are done with 3 things, that is hybridization, number of bond pairs and number of lone pairs. I hope you are getting it. These questions are seen many times in competitive exams and we should be very clear with it because they help us fetching a positive mark which can help us crack such exams. So, we are done with hybridization, we are done with bond pair, we are ready with the lone pairs. Let us move a step ahead and think about the structure. We also coin it as geometry. Remember very well, the total number of bond pair and lone pair together determine the structure. The total number of bond pair and lone pair together determine the structure. Henceforth, if the total again is 2, the structure will be linear. I am talking about the structure and the geometry which involves both the bond pair and the lone pair. If the total number comes 3, the structure has to be trigonal planar. I am talking about geometry or structure. If the total number is 4, it has to be TD, which indicates tetrahedral. If the total number is 5, it is trigonal bipyramidal. It is trigonal bipyramidal. If the total number is 6, it is octahedral. And if the total number is 7, it is pentagonal bipyramidal. So friends, be very clear that once you have the total number of bond pair and lone pair, you can always crack 2 things. One is the hybridization and second is the geometry. So I hope we are clear with 4 things: number of bond pair, number of lone pair, hybridization, or either you call it geometry or you call it structure. But friends, when you come across the word shape, the things change a bit. How do they change? So when it comes to shape, it is only the effect of number of bond pair of electrons. It does not involve number of lone pairs. And also remember that there are few structures, few compounds, few molecules in inorganic chemistry available where you do not get the second divisor. It means in the first step only the remainder becomes 0. In the first step only the answer over here will become 0. So if molecule has only bond pair and no lone pair, then very important, very easy, geometry equal to shape. Geometry equal to shape. Subject to condition, the lone pair has to be 0. So friends, we are done with 4 answers, left with 1 answer: number of bond pair, number of lone pair, hybridization, and structure and geometry. Now we have to also solve the 5th answer, that is the shape. I am just giving you some information for the shape which will make the things much more clear. Let us check for it. We are done with the number of bond pairs, number of lone pairs, the hybridization and the geometry. Let us go for the shape. Remember, it has to be done on the basis of few earlier answers, that is hybridization, bond pair, lone pair, geometry, and then you will come across shape. So if your hybridization is sp, you have 2 bond pairs, you have no lone pair, remember very well, the geometry will be linear and the shape will also be linear, because when there are no lone pairs, only bond pairs, geometry is equal to shape. If we are talking about sp2 hybridization, then your one combination will be 3 bond pair, no lone pair. Second will be 2 bond pair and 1 lone pair. So when you have 3 bond pairs and no lone pairs, it is trigonal planar, and the shape will also be trigonal planar. But when it is the combination of 2 and 1, definitely your geometry has to be trigonal planar. But in such a case, your shape changes to inverted V. Sometimes we have seen people spelling as bent, inverted V. The third one is sp3. you have three combinations over here. The first one is 4, 0, 3, 1 and 2, 2. Whenever I say 4 and 0, the geometry will be tetrahedral, the shape will also be tetrahedral, and as it is inorganic chemistry, we will be asking to write an example which does not involve carbon, and therefore it will be SiCl4, silicon tetrachloride. Now there are two molecules, ammonia and water, which do not obey our formula but are the best suitable examples for this combination, where the geometry for ammonia and water will be tetrahedral, whereas the shape would be pyramidal and the shape would be bent or inverted V. So friends, this will make it very clear. It will give you a crystal clear idea that whether the hybridization is sp, whether the hybridization is sp2, or whether the hybridization is sp3. These are our targeted answers. So over here we had XeO3, it was sp3. So yes, it is sp3. Was it a 3+1 combination? Yes, it was a 3+1 combination. So the geometry has to be tetrahedral, but the shape has to be pyramidal. And we can check over here, xenon, O, O and O along with this. So when you consider this, you will have such a geometry which is a tetrahedral. But when you are going for a shape and you do not consider the lone pair, you will have the pyramidal structure. Always remember, the sigma is counted in hybridization, the pi is not counted in hybridization. The pi is not counted in hybridization. So do not get confused, pi is never counted in hybridization. I am not telling that the lone pairs are not counted. The lone pairs are counted. The bond pairs are counted, but the bond pairs which are axial are counted, which are equatorial are not counted, and pi are equatorial. So friends, I hope you are clear with this idea. Let us move still into detail. And over here, we will add one more thing. Along with hybridization, let us add type of molecules. So when you have sp hybridization and a two bond pairs, it is AB2. Now what is this AB2? A is the center atom in the molecule and B are two with context to two bond pairs. For example, if I say BeCl2, then BeCl2 has Be as the center atom A and 2Cl as B2, because in BeCl2 both the chlorines are attached with beryllium by a single sigma bond pair of electrons. It does not involve any lone pairs. If it had involved lone pairs, we would have indicated by a symbol L. Let us go for spt. As it is three bond pairs, we will always write it as AB3. But if it would have involved one lone pair and two bond pair, I would have written AB2L. Going for the case of SiCl4, I would be writing AB4. As one lone pair is involved, AB3L, and as two lone pairs are involved, AB2L2. But friends, once we are done with all these things, at any moment, whenever we get a question, we should be able to solve. So let us start solving the questions here itself and then move ahead. Now, before starting new question, XeO3, bond pair were 3, lone pair was 1, sp3 tetrahedral. Now as it's a combination of 3 plus 1, its shape will be pyramidal. So now I am taking one question each for these examples, and we will be taking the help of this chart and going through the answers. First one, we will be taking the example BeCl2. Remember, whether you take BeCl2, BeH2, BeF2. The answers remains the same. BH2 does not completely involve the whole set of formula, but it will give you the same answer, and it is correct. Let us check for BeCl2. The first step or ours is always to calculate the number of valence electrons. If we talk of beryllium, it is 1s2, 2s2, and so there are 2 valence electrons in the outermost shell. So you have 2 for beryllium, 7 for each halogen, 3s2, 3p5, 7, and 2 times. So you will end up with 16 electrons. I hope it's working. Now, if the answer was between 2 to 8, we would have divided by 2. But the answer over here is between 9 to 56. Henceforth, we would be required to divide it by 8. So it is 8, 2 times 16. And here you can see that the divisor is helping us get the answer or the remnant 0 in a single step. So when you get the remnant 0 using a divisor, then it is always possible that it will only have bond pairs. So over here in BeCl2, you have 2 bond pairs, 0 lone pairs. So as the total is 2, it is always the sp hybridization, and as the total is 2, there are no lone pairs, so the geometry is equal to the shape. So it has linear geometry and linear shape, and as there are 2 bond pairs, the center atom would be A, that is Be, the 2 sides atom would be B, that is AB2, and so the molecule will be AB2, and as it is linear, the bond angle will be 180 degree. I hope, friends, one single mathematical formula of school time has helped us get the answer in a very positive way. So, it is the sp hybridization that we are able to solve using the example BeCl2. Friends, BeF2 can be calculated, BeH2 can be calculated. Now, let us move a step ahead. So, we will think of moving a step ahead and taking another example. So, I hope we are clear with this example. Let us go with sp2 and AB3 type. You have BF3, you have BH3. Let us go with BH3 this time. Boron in its valence shell has 3 electrons. One hydrogen has 1 valence, and there are 3 such hydrogens, so the total is 6. When the total is 6, you divide it by 2. Your answer in a single step will fetch you remainder 0, and as there is only one divisor you are getting, henceforth you will say that 3 equivalates to sp2 hybridization, 3 bond pair, no lone pair. Therefore, it will be a trigonal planar geometry and a trigonal planar shape. And as all the 3 are bond pairs, the molecule will be AB3. So, friends, over here, you can very easily say that whether it is BH3 or whether it is BF3, you are very closely encountering AB3. Let us go a step ahead and let us solve AB to L. Friends, whenever I discuss AB to L, I always discuss a question that has been asked several times, that are CO2 and SO2 having the same shape, having the same number of bond pairs, having the same number of lone pairs? And when you will solve, you will get an idea. And this will help us answer the application part, that is isostructural and isoelectronic. Have a look. CO2. The valence shell over here in CO2 will be 4 valence shell electrons. Now I'll be going a little quick. 1s2, 2s2, 2p2. So 4. Oxygen has 6 valence electrons into 2. So it will be 12 plus 4, 16. Be very sharp. It is 16. 16 divided by 8. 8, 2 times 16, it is 0. So your total answer is 2. So when your total answer is 2, it is sp hybridization. As there are no lone pairs, only bond pairs, so 2 bond pairs, 0 lone pairs. So shape is equal to geometry, and that is linear. So it will be C double bond O, and just now I have taught you that pi is not involved in hybridization. So this is what it is, CO2. But now friends, let us check SO2. When it is SO2, the valence electrons are 6 plus 2 into 6, so it is a total of 18. So the total is not same. When, remember very well, when the total is not same in the terms of electrons, they are not isoelectrons. When the total is not same in the terms of electrons, they are not isoelectrons. So which of the following questions or which of the following options are isoelectronics? Here they are not isoelectronics. So SO2, 18, so you have 18, you divide it by 8, it's 8, 2 times 16, you are left with 2, 2 1 times 2, and your answer is 0. So now you have a combination of 2 bond pair and 1 lone pair, a total of 3. You have 2 bond pair, 1 lone pair, and it's a total of 3. So when it's a total of 3, friends, your hybridization has to be sp2, but it will not be ab3, it will be ab2l because it involves both a lone pair and a bond pair. So you have sulfur, double bond O, and a lone pair, and therefore it is no more a linear structure. It will have the geometry trigonal planar, but the shape would be inverted V, because in the shape you do not go for the lone pairs. So CO2 and SO2 do not have the same shape, do not have the same total number of electrons, and therefore they are not isoelectronic. Apart from this, CO2 is Ab2, SO2 is Ab2l. So the involvement of a lone pair. Friends, the example was SO2. So this is what molecular structure is all about. Now let us move a step ahead and think of another example in the sp3 category, SiCl4. You can check over here. Silicon has 4 valence electrons. Each chlorine has 7 and 4 such chlorines. So 4 plus 28, you will end up with 32. So it's 32 divided by 8 because it is in the range of 9 to 56. So 8 4s are 32, and your answer is 4, which involves sp3 hybridization. And as the answer is 4, there are no lone pairs. So geometry equals to shape. So it's a tetrahedral. I hope you are clear. We will involve 2 more such questions before we could move ahead. Friends, if it is NH3, we will not go with the formula because the formula does not work here precisely. But for NH3, it is 3 bond pair and 1 lone pair. So it's a 3 plus 1 combination. It's a sp3, it's a tetrahedral geometry, and it's a pyramidal shape. It's a pyramidal shape. You would have marked that sir is not discussing the bond angles, because there will be a separate class on bond angles because it is a different class of things. So I am not involving bond angles, but I hope you are clear with this example. Let us go for H2O and H2S. They are also exception. They do not follow our formula. So when it is H2O or H2S, it is something like this. So you have 2 bond pairs and you have 2 lone pairs. Overall it is sp3, but it has 2 plus 2 combination, so it will be tetrahedral and bent, and it will be the type Ab2L2. So friends, I hope you are clear, or you are getting the idea that if you will be getting questions, or if we are going to get encountered with such type of questions, we will be very easily able to answer, because now we are clear with what we are doing. So we have done AB2, that is SP. We are clear with AB3 and AB2L, that is SP3, and we are also done with AB4, AB3L and AB2L2, that is also in the case of SP3. So now let us move ahead. Let us think of one more higher step, that is SP3D. When it will be SP3D, I will give you 4 different examples, 4 different combinations. AB5, AB4L, AB3L2, AB2L3. Friends, remember the B indicates the number of bond pair, L indicates the number of lone pair. And when you have 4 such combinations, you at least require 4 examples. So the example number 1 is PCl5. Let us check. When I say PCl5, phosphorus has 5 valence electrons, 3s2 3p3. Each chlorine has 7 multiplied by 5. So it will be 5 plus 35. Friends, it is 40. 40, so I will be again divided by 8. So 8 5 times 40. Single step and the answer is 0. Whenever single step and the answer is 0, bond pair are 5, lone pair is 0, total is 5. So hybridization will be sp3d. The type of molecule will be, as it is all 5 bond pairs, 5 bond pairs, so it will be 5, and geometry will be equal to shape. So from the memory of our table, I will be writing trigonal bipyramidal as my geometry as well as my shape. So when you have PCl5, when you have PF5, when you have PH5, you always involve such type of answers. Friends, let us move a step ahead. So I hope we are clear with the first example, and now we are moving towards the second example. Be very sure when you are solving such questions, because they give you marks. And the second question for over here for AB4L, let us try Sf4 Sulphur Tetrafluoride. So whenever I say Sf4, see what happens. Sulfur has 6 electrons. I hope you are knowing it. Group 16. One fluorine has 7 and 4 such fluorines. So 6 plus 28, you are ending with, friends, 34. When you are ending with 34, be very clear, you are dividing by 8. 8, 4 times 32. 2 is your remainder. You will divide it by 2. 2 1 times 2, and my answer is 0. So you have 4 bond pair, you have 1 lone pair, and so collectively it is 4 plus 1, 5, and henceforth it is sp3d. You are right. But as it is 4 bond pair, 1 lone pair, the molecule will be AB4L. You can write AB4L1, but 1, if written or not written, always suggests 1. So it is AB4L. So you are having the hybridization, you are having the type of molecule, the number of bond pair, the number of lone pair, and when it is sp3d, it has to be trigonal bipyramidal in the geometry, but over here the shape would be different. As the geometry over here was trigonal bipyramidal and the shape was trigonal bipyramidal, over here the geometry would be trigonal pyramidal, but the shape changes. It is S, F, 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 and a lone pair. So what happens, I'll just give you an idea. This is my sulfur, this is 1 fluorine, this is 2nd fluorine, this is 3rd fluorine, and this is 4th fluorine. So there are 4 fluorine. Now, ideally, when you have a lone pair over here, it is no more trigonal bipyramidal, because if it would have been trigonal bipyramidal, it would have been something like this, with 1 pyramid on the top and 1 pyramid on the bottom. But you have 4 bond pairs, and the 5th one is the lone pair, and so the complete shape changes, and that Change in the shape is what we are discussing now. So it is now 4 sulfur in a plane and a lone pair on the top. But now remember what I am speaking. 4 fluorine in a plane, but 1 lone pair on the top. Which lone pair, bond pair repulsion, VSEPR, lone pair, bond pair repulsion, lone pair, bond pair repulsion, and lone pair, bond pair repulsion. So these 4 bonds will come down a little. So it will be something like a square, but not a complete planar square, a square pyramidal. So it will be something like this. So it will now become square pyramidal. ऐसे घर की छत जो थोड़ी सी झुकी हुई है, a bent rooftop, square pyramidal. So here you will have square pyramidal. I hope friends you are getting it correct. Always remember, I have one more very lucrative example over here. Let us check what happens in that example. Everything will be similar to Sf4, but at the last moment the shape will change. Let us take the example and check whether what we are speaking is correct or not. XeO2F2. Xenon has 8 valence electrons. You have 2 oxygens, 6 each. You have 2 fluorines, 7 each. So 8 plus 12 plus 14, it's 20, and 14, 34. So the total is 34. Henceforth, remember very well, it is going to be divided by 8. So 8 4 times 32, you are left with 2. Again you will have 2, 1 times 2. So same combination friends, 4 plus 1, 5. When the total is 5, it is always sp3d, but when it's a combination of 4 plus 1, it is always AB4L. So the geometry will be trigonal bipyramidal, but over here the shape will be seesaw. So it's an axis, the 2 stands of the seesaw, the first fluorine and the second fluorine, the seesaw. So the shape is changing over here. So the square pyramidal shape relates to Sf4 and the seesaw relates to XeO2F2. So friends, you can see the complete horizon of the subject over here, that just a change in the atoms helps you get a total new shape data for a molecule. And this is why molecular structure is important when we are trying to appear in different competitive exams. So it was XeO2F2. Let us still move a step ahead. When we are still moving a step ahead, let us check. So over here friends, just for ourselves, I will be writing 2 examples. One is square pyramidal and the second one is seesaw. Let us move a step ahead. I am taking an example for AB3L2. Now over here at this particular junctions, examples are very important. And AB3L2 is fundamentally a hybridization for interhalogen compounds. So the question comes, what are interhalogen compounds? Those compounds, those molecular structures which are only made up of halogen, where the central atom working as an halogen is a bigger one and the molecules surrounding it are the smaller one. It is called interhalogen compounds. So friends, over here we are taking ClF3. So when we have ClF3 as our target in the interhalogen compounds, you have 7 electrons from chlorine, you have 7 electrons from fluorine and 3 such fluorines. So the total would be 28. Friends, be very clear that when the total is 28 and you are dividing by 8, it is 8 3 times 24 to 2 times 4. So it is 3 plus 2. The total is 5. So when the total is 5, it is sp3d hybridization. It has 3 bond pair, it has 2 lone pairs, and therefore it's a combination of AB3L2. No doubt the geometry never changes, it is trigonal bipyramidal, but you have a very unique shape over here, and that's a bent T shape. How does it come? FCl, 1 lone pair, two lone pair. Friends, this is one surface. This is one surface, the trigonal bipyramidal. This is the trigonal. You have one pyramid on the top, one pyramid on the bottom, but because of this two lone pair repulsion, that bond or that pyramid lines would not be straight. It will be a little bent, and therefore I have seen people coining it a bent T shape. So remember this bent T shape for IF3, ICL3 and BRF3. But as I told you, it is popular for interhalogen compounds. It is popular for interhalogen compounds. I hope you are clear with this. And once you are clear with this, let us move ahead with the AB2L3 type. So whenever I say the AB2L3 type, I will change the example. And the example in the AB2L3 type now would be Sf4. We are now involving the xenon fluoride molecules. Remember the wide spectrum of sp3d. It involved a complete inorganic molecule. It involved a fluoride molecule. It involved, apart from fluoride, the oxyfluoride molecules. And now, after interhalogen, we are moving for xenon fluoride molecules. So Sf4, it is 8 from all the inert gases other than helium, 7 from halogen multiplied by 2, so it is 8 plus 14 and that will be 22. Whenever you have 22 as your total number of valence electrons, you divide it by 2, so it is 8, 2 times 16, you are left with 6, it is 2, then 2, 3 times 6, so it is 2 plus 3, a total of 5. So when it's a total of 5, it is always sp3 dehybridization. Bond pair are 2, lone pair are 3. So when you have it's a 2 plus 3 combination, it's an AB2L3 type. It's an AB2L3 type. Friends, be very clear, be very precise that AB2L3 will always give you a trigonal bipyramidal geometry, but when it comes to the shape, it is Xe, F and F. It will be a linear shape because we know that lone pairs are not involved in the shape. So it would be a linear shape. So you can see the huge spectrum of shape that you have received today from this video is AB5, it's a trigonal bipyramidal shape. AB4L, you can have square pyramidal, you can have seesaw. AB3L2, you can have a bent T shape, and AB2L3, a linear shape. So friends, sp3d, a very important class of hybridization that is done today. Let us move a step ahead again. Now we will be moving towards sp3d2. No matter, it has few examples when it comes to competitive exams compared to sp3d, but nevertheless it is important. Everything that we have in the molecular structure is important. So here you have sp3d2. Whenever you have sp3d2, the types of molecule we will be encountering is AB6, AB5L and AB4L2. So first of all, let us check for this 3 set of examples and then move ahead. Whenever I say AB6, be very clear, be very precise that I am telling SF6. So whenever I say SF6, let us check. 6 electrons from sulfur, 7 from each fluorine, and I have 6 such fluorine. So 6 plus 42, I will end up with 48 electrons. Sir, 48 electrons divided by 8. 8 6 times 48. Sir, in a single step you are getting the answer 0. All 6. So it will be sp3d2 hybridization. A B6 molecule, bond pair are 6, lone pair are 0, which helps us write always that the shape is equal to geometry, and henceforth the shape will be octahedral. So over here 6, 0, octahedral, octahedral. I hope the lecture that we are discussing now is and will be useful to you for cracking your competitive exams. Let us move a step ahead, that is AB5L. whenever I say AB5L or whenever I say AB4L2, we should have such examples with us. Over here I have XeOF4 and over here I will be probably taking XeF4. Xenon oxyfluorides and xenon fluorides. See the spectrum this xenon has. XeOF4. Xenon has 8, 6 with the oxygen, 7 with each of your fluorine. So it is 28 and 6, 34 and 8, 42. So whenever you have 42 involved, it is 8, 5 times 40. You are left with 2. And 2, 1 times 2, so it's a 0. So it's a 5 plus 1. A total is 6. So when it's a 5 plus 1 total 6, nevertheless it is sp3 D2 hybridization. It's a 5 plus 1 combination. So you have 5 bond pair, you have 1 lone pair, and when you have this combination of 5 bond pair and 1 lone pair, the type is AB5L. Remember, the type is AB5L, but the hybridization being sp3D2, its geometry will be always octahedral. But what about its shape? Let us check. It is 5, it is 1, it is octahedral. Now I am just trying to have F, 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 F. Something like this. So over here, this lone pair would not be counted when it comes to shape. So you will have the 4 fluorine and oxygen. This will push them downwards. This pi bond will push them upwards. But the probability of pushing them downwards will be more than upwards because this is a pi cloud and this is a free cloud. Pi cloud is restricted between the bond, whereas the free cloud is not restricted between the bond. Lone pair always has a free cloud, and therefore it will be something like pyramidal on square, but it will be something, an inverted type of a square pyramidal. So be very clear, it's a square pyramidal, what people write in the book, but I would suggest a word on the top of it, that is inverted square pyramidal. Now let us go with XeF4. Xenon has 8 electrons, 1 fluorine has 7, you have 4 such fluorine, so it is 28 plus 8, 36. 36 is your answer. 8, 4 times 32, 4, 2, 2 times 4, so it is 4 plus 2, a total is 6. So remember friends, it is 4 plus 2, so AB4, L2, octahedral, but over here the shape will be simple square. Why I'll tell you. Xenon in the center, F, 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 F. 1 lone pair on the top, 1 lone pair at the bottom, both will cancel each other. You will only have XeF4, so it's a square shape. So friends, very very important concept, that is sp3d, and we are done with this sp3d2. Sorry, it's not sp3d, it's sp3d2. Now let us take the last example in this series, that is sp3d3. Friends, remember very well, the examples that I have taken in this class are all inorganic molecules. So sp3d3, it would be the type AB7, 7 bond pair, 0 lone pair. Let us check whether we are getting it or not. The example is interhalogen compounds, IF7. Iodine is 7, each fluorine is 7, and you have 7 such fluorines, so the total will be 56. So when your total is 56, friends, is 8, 7 times 56, and you will be ending it in a single step. Whenever you end your answer in a single step, all of them are bond pairs. The lone pair is 0, so the combination is right, and the geometry will be pentagonal bipyramidal, and the shape will also be pentagonal bipyramidal, because when you do not have the lone pairs, geometry is always equal to the shape. And therefore I in the center, F, 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 and 1 F at the top and 1 F at the bottom, so it's a pentagonal bipyramidal. Friends, this was just a theory of what we were doing, but this is not the textual theory that we were discussing. We had all the ideas up discussed in these 45 to 50 minutes of the class. Now, if on this discussion we have the examples what we discussed, CO2, SO2, BH3, BF3, NH3, PH3, H2O, H2S, PCl5, PF5, PH3, XeO2F2, Sf4, ClF3, BrF3, IF3, BrCl3, XeF2, XeF4, XeOF4, XeO3, SF6, IF7. These are some of the inorganic molecules to which you can answer randomly in a very quick manner, and I have taken most of the examples. I have not left a single example. You can also have IF7. These are simple questions, but they are asked several of times. Let us take few other examples. NO2 minus, NO2 plus, SO4 2 minus, PO4 3 minus, SO3 2 minus. They will also give you always a correct answer. We can show you. Let us take one random example. NO2 minus and NO2 plus. This combination in the form of hybridization has been asked several times. NO2 minus. Nitrogen is 5. Each oxygen is 6. Multiply by 2. When you have minus 1, you have 1 extra electrons. So it is 5 plus 1, 6 and 12. It's 18. Friends, be very clear. It is 18. So I'll divide it by 8. 8 2 times 16. I'm left with 2. I'll divide it by 2. 2 1 times 2 and henceforth it's a 0. So therefore it is 2 plus 1 and your total is 3. So as your total is 3, nevertheless it is sp2. But it has 2 bond pair and 1 lone pair. It has 2 bond pair and 1 lone pair. Now let us go for NO2 plus. Let us check what will happen when you have NO2 plus. You have 5 from nitrogen, 6 from each oxygen and 2 such oxygen, minus 1 because it's a plus charge. So you will have 16. 12 plus 5, 17 minus 1, 16. 16 is one of the easiest answer to get. 2, so it will be sp, no lone pair, only 2 bond pair. So you can just see the easiest way to get the answer. You have 2 bond pair, no lone pair, and therefore it will be sp. So which of the following do not have the same kind of hybridization? If this is given and this is given together, either of these can be your answer. If you are supposed to find out what is not sp2, this will be your answer. What is not sp, this will be your answer. Friends, I ask you to calculate such type of questions using the formula. That is not mine, but I have been going through many different books, many different videos, and I come through this formula since last 5 to 7 years. And this formula is working in n number of examples. I'm not telling it works in all examples, but definitely it works when it comes to competitive exam. And this is nothing but cracking of competitive exam. So it will work. Let us have another combination. I have NH3 and I have BF3. Do they go hand in hand? No, they do not go. Why? Because it is 3 from valence of boron, 7 from fluorine, 3 such fluorine. So I will end up with 28 plus 3, 21 plus 3, 24. So it is 24, I will divide it by 8. So 8, 3 times 24 beta in a single step. So it will be sp2, it is Av3, 3 bond pair, 0 lone pair. So it's a very important molecule, trigonal planar. Geometry and shape are same. But just now I told you that is our exceptional. So it is nitrogen with 1 lone pair, 3 bond pair, and therefore it's a tetrahedral geometry and a pyramidal shape. It's a tetrahedral geometry and a pyramidal shape. So they are not having same shape, they are not having same geometry. So this comes to an application. They are not isostructural. They are are not isostructural. Even they are not isoelectronic. Why? Because the electron number is also not same. So this is important. This is what we should know. So friends, the topic that was involved today in this first class was a complete know-how about the geometry, the shape, the number of bond pair, the number of lone pair, the type of molecule, especially the inorganic molecules, and the hybridization, and few examples. One more video you will be getting in this particular class, where I'll be just framing out few examples that have been asked in the earlier exams, along with isostructural, isoelectronics, hybridization, type of molecules, their shape and their geometry. So stay tuned. If you have any questions, you know my contacts. You can contact me by a simple call, or you can even write an email to me. The comment box is always open. You can comment it there. Thank you for your support. Be in touch. Thank you.